Well, hello once again, advanced algebra students. We're ready to go ahead with our Friday lesson here, our Friday notes, which is on 13.4 and sine function graphing. So we introduced how we could turn the sine ratio into a function last class, and now we're going to talk more extensively. We looked at what the graph looked like last class, but now we're going to talk more extensively about just how we actually can graph the sine function and some characteristics of it. So let's go ahead, let's take a look. Remember, just pause the video anytime you need to get more written down. All right, so our basic function looks like this. This is y equals a times the sine of b theta, or you can write that as bx. You could think of it as either way, b theta or bx. Either one would be appropriate. If you want to, you can even write here, or y equals a sine of bx, because if we want to think of it in terms of x and y inputs, then we can do that. But using theta does remind us that the x is measuring an angle and the y is measuring a ratio. The key, really, to knowing what the graph looks like are these numbers a and b, because a represents vertical stretch or shrink, b represents horizontal stretch or shrink. So that vertical stretch or shrink, when we're talking about a trig function, which has a wave pattern to it, like a sine function does, we don't worry about whether there's a reflection going on or not. We're just concerned with the absolute value of a. If a was negative, it would reflect it, but it's still going to stretch it the same amount. And so we're just concerned with that vertical stretch or shrink, and we have a special name for it. It's called amplitude. So we introduced that last class. But the stretch or the shrink we call the amplitude. The next thing that we look at is when we can consider b, we consider the horizontal stretch or shrink that's happening. And one way of describing that, since this is a cyclical function, is we can look at 2 pi over b, that is the period, that is how long it takes, in other words, long length measured in the theta or the x variable, does it take to make a complete cycle. Related to that is this reciprocal, which we call b over 2 pi, which we call the frequency. And the key thing here, the period is how long it takes to make a complete cycle. Its reciprocal, frequency, is how frequently it makes a complete cycle. So in other words, what this is here is, in other words, it's how many cycles does it make in a given amount of time. This is how long per cycle. This is cycles per length per 2 pi is the idea of what's happening here. All right, so let's look at this one here, 33. So 33 in your book, what it asks us to do is it says determine the number of cycles each sine function has in the interval from 0 to 2 pi. Find the amplitude and find the period of the function. So looking at this, the cycles in essence would be the frequency. So to go ahead and do these, first off, amplitude is easy. It's 1. But we're going to go number of cycles from 0 to 2 pi. So to get this, all I have to do is I have to look at this here, and that is the frequency, so I can just simply put pi in for b and get pi over 2 pi. The pi's cancel and I get 1/2. So the number of cycles from 0 to 2 pi that it makes is it makes 1/2 of a cycle. So it doesn't make a full cycle, just makes 1/2 of a cycle. Okay, then for the next thing, it says find the amplitude. Like I said, the amplitude is easy. It's the absolute value of what's multiplied here. We don't see anything, so we know it's just 1. And then the frequency, the period. The period is the reciprocal of the frequency. So I could go ahead and I can do my formula. Here's my formula, 2 pi over pi, putting in pi for b there. And I can do it like that, or I can just simply take the reciprocal of the frequency, since I already have it, say the reciprocal of 1/2 is 2. It's that quick and easy. All right, so that's definitely some of the types of problems you're going to have to do. You're going to have to do ones like 33. Let's look at another example. 35. Want us to do the same thing with 35. So notice first thing we need is we need the number of cycles. So the number of cycles, we're going to do frequency here. So the frequency, if I put in, notice my value here is 1 is what my B is. So I got 1 for B over 2 pi. So it makes 1 over 2 pi cycles in that time. In other words, it makes 1 cycle for every 2 pi is in essence what's happening. And then for B, the amplitude is 5. It's the absolute value of this -5 here. And for C, the period is the reciprocal of the frequency, or just 2 pi. All right, next one, number 41. 41 is asking us to do something different. 41, we're given this equation, y equals 5/2 sine of 2 theta, and it wants us to find the period and the amplitude and then sketch it. So first, let's find the period and the amplitude. That's pretty easy. So if I want to do the amplitude first, it's usually the easiest to do. I just want the absolute value of 5/2. That's just 5/2. Very simple. So that just means it's been stretched 2.5 times. And then for the period, my B is 2, so I have 2 pi over 2, which simplifies down to pi, so my period is pi. Now when it goes and says to sketch this, notice since my period is 2 pi, what I need to do is set up my graph, and I want to set up my graph between 0 to 2 pi. It says I need to do that, so when I sketch out my graph, I'm going to sketch out my graph like this, 0 to 2 pi. But I know that it makes a full cycle. Oh, sorry, you can't see that. I know that it makes a full cycle in terms of pi. So that means that I've got to put a dot here for pi, halfway between 0 to 2 pi. And I know that's when it's got to go its full cycle. So it must go up to its peak, down to its lowest, and then back up to get to pi right there. So at that point, I just take half of that distance there, between there, and I put a dot, and know that that's where it's got to go up and come down. So I just basically divide this into 4 sections. 1, 2, 3, 4, like that. And I make it be at its peak in 1/4 of the distance. Halfway there, it's back down. 3/4 of the way there, it's lowest, and there. Now all I have to do is make sure my Y scale is correct. So for my Y scale here, I've got it, it's going to be 5/2 or 2.5. So I know its peak has to be at 2.5, and its lowest point, its minimum, has to be at -2.5. So I just make sure it gets up to those values there. Just make sure everything's labeled nicely, and you have yourself your graph, just between 0 to 2 pi. All right, let's look at another example. 43 is the exact same type of problem. So we have 0.4 sine of 3 theta. So first, let's find the amplitude. That's very easy. It's just 0.4. We can think of that as 2/5 if we want to. And here's our B. So it's going to be 2 pi over 3. So we know it makes 1 full cycle in every 2 pi over 3, or 2/3 of a pi, if you want to think of it that way. So as I go ahead and do this, notice I also see that if it, in this case here, see it's been, this horizontally shrinks it by 1/3, so it's going to make 3 full cycles getting to 2 pi. So I'm actually going to have 3 full cycles sketched here. But when I go to sketch my graph, notice I'm just going to go ahead and I'm going to sketch, and I'll see if I can do this on a piece of scratch paper to actually show you the process that I would be using here. Let me grab something that's a good piece of scratch paper. I don't want to write on stuff that I'm using for other things. Let me see. Let's see what this is. Oh, I'm going to grab. Okay, I've got a piece of scratch paper. So here, let me explain how I would do this. So what I'm going to do is I'm going to go here And I'm going to sketch, I know that it makes a full cycle at 2 pi over 3. And then I'll just divide that up into 4 parts. And so, and I know that in this case, if this is 1, and this is -1, at 2/5 is where it has its maximum and minimum. That's my 0.4 right there. And that's my -0.4 right there. So it's going to start here. 1/4 of the way it's going to be up to the top there at the 0.4. It's going to come down and hit there. It's going to go down to this minimum point here and be back up. So there's my full cycle in 2 pi over 3. But remember, I have to go out to 2 pi. So I'm going to have to go another 2 pi over 3 out here. So now I will be at 4 pi over 3 when it completes its next cycle. And then finally I'll be here at 2 pi, 6 pi over 3, which is 2 pi. That will be when it completes its full cycle. So that's when my graph is done. So I just have to go here, and I'm just going to keep this going the same. Oops. Got to go up halfway, so I got to go up to my peak and down. Peak and down. And it looks like that. Doesn't have to be real precise, but you need to have it labeled so I can clearly see what the period is, or we can clearly see how long. We need to know that we graph it between 0 and 2 pi. We need to see those maximums and minimums based on the amplitude. So if you do that, you've got it. So here's my sketch. Notice you can see just how I did this here. There's 2 pi over 3. I made sure I made 1 full cycle in that amount of time. Made sure I labeled this 1, -1, so we could see this really is at 0.4. Made it go like that. And then you can see as I went through, continued it on. And we know that we got all the way through as this became 4 pi over 3 right here. And we ended up being at 2 pi there when we were done. So, and it would make 3 full cycles for that time. All right. There's your homework. 13.4, 27 through 30, and then 32 through 44 even. All right. So I hope those go well for you. And if you have questions, you can shoot them to me through Google Classroom. Remember, we do have a Zoom session coming up on Tuesday where you can get any questions answered. And so that would be on Tuesday at 1:30 if you have any questions and need any help on anything. If you need personal help on something, even if it doesn't work to be there, give me a email or something and we can set up some time. All right. Hope you're doing well and have a good weekend.